Alright, so we're going to have a look at pulley problems today. Now, one of the most important parts of the pulley problem is the fact that there are two systems where we have A and we have B. Now, if we draw the free body diagram, A and B both have an option of a force acting up and a force acting down. Well, obviously the force of gravity is acting down, force of gravity on A and on B, but we also have tension on either one. Okay, now one of them has to be bigger than the other. So I'm going to make B greater than A. So the mass of B is going to be greater than the mass of A. So logically, B is going to be going down. So that means I'm going to take that direction as positive. Now A would logically be moving up because it's connected to the same string. Now we're going to take the direction of motion as positive. So the direction of motion is positive. Okay, now that means down is positive for B, up is positive for A. This is important because when we start making the two equations, that will play a part. Alright, so A, we first start with the idea that the net force is made up by the mass times acceleration. And it is also going to be made up of all the forces added together. So the net force is equal to the tension minus the force of gravity, which is acting on A, because the force of gravity acting in A is acting in the negative direction. Whereas for B, the force of gravity is acting in the positive direction, whereas the tension is acting in the negative direction. This is really important because if we now take those into account, then we have the mass of A times by gravity, which is equal to tension minus the force of gravity on A. Then we have the mass of B times the force of gravity, which is the acceleration due to gravity, which is equal to the force of gravity on B minus tension. Okay, now this is also going to be gravity, the acceleration of each. Alright, so let's just say A is equal to 1 kilogram and B is equal to 2 kilograms. Now we have a mass. So A is only going to have acceleration T and 9,8. On the other hand, B is going to be 2A, which is equal to 2 times 9,8, which is 19,6 minus T. Alright. Now, if we're looking for just T or A, let's say we're looking for A first, we need to rearrange this so that our T is by itself. So A, move that across, gives us 9,8 minus T. 2A minus 19,6 equals minus T. So therefore T is equal to 9,8 plus A. But T here is 19,6 minus 2A. So we have our two equations. Right. Now, therefore we can substitute 1 into 2. So therefore we have 9,8 plus A is equal to 19,6 minus 2A. So when we rearrange this, we get 3A is equal to 9,8. And then we have, we have A is equal to 3,27 meters per second squared. Okay, now we can just substitute that straight in. So let's say into number 1. So we have T is equal to 9,8 plus 3,27, which is equal to 13,07 newtons. Alright, and that is a basic pulley problem.